Okay, so now that we've drawn the picture and set up the equation, it's time to solve these problems. This, just as a refresher, this was the first example we looked at. This is the diagram that we drew, and this is the equation we set up. So the real question is, how do we go from here? If we have tangent of theta equals 300 over 750, how do we solve for theta? Well, fortunately, we've already done that lesson where you solve for the unknown angle. As you know, when you're solving for an angle, you use an inverse trig function. So this should be review. Now, one thing to note too also is 300 over 750 can be reduced by dividing both of these by 150. If you do that, you get 2 over 5. So now how do you solve this out? You take the inverse tangent of both sides to get rid of the tangent here to get theta by itself, and in your calculator you're going to plug in tan inverse of 2/5. So again, when you're solving for an angle, you use inverse tangent of whatever they give you. So you could plug in inverse tangent of 300 over 750. You're going to get the same answer. So let's pull up our calculator and see what we get. Okay, so I have my calculator pulled up here. I'm going to click on settings, make sure I'm in degrees. So that's important. I don't know if you can see that or not. Yeah, there we go. So we have it in degrees now. I'm going to click that again. Then I'm going to type in tan. Actually, we're going to go to the functions here. Go back here. Click on functions and click on tan inverse. And again, you can type in the original, what they gave you, or you can type in the simplified 2/5. And either way, I'll just show both ways. If we go back to function and type on tan inverse and type in 300 over 750, we get the same thing, 21.8. So that's why we get theta is approximately 21.8. The final step is to write out the answer verbally. Just remember what the original question was asking, at what angle should the camera be pointed. So our final answer is the camera should be pointed at an angle of approximately 22 degrees to ensure that the image of the shuttle is captured. So that's it. You're just using a previous lesson we've already learned to solve for the unknown variable and answer it verbally. Let's look at example 2. This was the question. You can read it yourself. You can pause and read this. We've already read it before. Here is the diagram. Again, we've drawn this and done this in the previous lesson, drawing pictures. We set this up in the last lesson. So in this one, we have sine of theta equals 6 over 7.5. So again, since you're solving for an angle, we will be using the inverse trig function. In this case, since it's sine, we will be using inverse sine. Algebraically, the way that we show that is we take the sine inverse of both sides. Now we have theta is equal to sine inverse of 6.75. Sine inverse of 6 over 7.5, and now it's time to pull out the calculator. So again, going to the Desmos calculator, we're going to click on functions, sine inverse. We'll type in 6 divided by 7.5, and we get 53.13, which is where this number came from. And again, to put this in context, the answer is asking at what angle is the observer viewing the plane. In other words, what is this angle right here? The answer we just figured out, which is 53.13. We'll answer that verbally. It's the observer is viewing the plane at an angle of 53.13 degrees when the plane is 7.5 miles from the observer. That's it. You know, this might actually be the easiest part of all of this because it's more or less calculator work. It's more or less just getting the variable by itself. Again, this was example 3, and it was asking how high is the space shuttle when the camera captures it. And again, you can read this yourself again if you want, pause it, but we did this in a previous video when we drew the pictures. So here was our diagram. Now in this example, we're solving for x. So we're not solving for an angle, we're solving for a length of the triangle. So when you plug it in and set it up, we had tangent 30 equals x over 500. And I asked you guys, you know, how do you get the variable by itself? Well, since the 500 is on the bottom of the fraction, what you have to do is multiply both sides by 500 to get it out of the bottom. That way the 500s cancel on the right, and you're left with 500 tan 30 equals x, and now you can just plug this into the calculator. And again, I like this calculator a lot because it's very straightforward. If I type in 500 tan 30, it automatically gives me the answer, 288.67. Now I will say this, you know, you can actually solve this without a calculator right up into the point, basically you can solve it a different way, okay? if you know your unit circle well, or if you know your trig values at 30 degrees well, tangent of 30 is square root of 3 over 3. You could have also realized that and then multiplied both sides by 500 to get 500 radical 3 over 3. That's also going to give you 288 or 289 when it's rounded. Either way, we get 289 meters when we round it equals x. That's just the answer we got here, rounded. So final answer, putting that into context, the space shuttle is around 289 meters high when the camera captures it. Again, that's what the question asked, how high is the space shuttle? And in the context of the picture, this would be 289, the height of this triangle. All right, let's look at the last example. It was asking how far away is the plane. So again, it's asking for, a side length of the triangle. So we're going to be using a regular trig function, not an inverse trig function. In other words, this was the picture we drew in a previous lesson and previous video. We're solving for x this time. This is the way we set it up. Sine of theta equals O over h. Sine of 33 equals 6 over x. Now this is important. In this case, x is in the bottom. So how do you get x by itself? Well, first of all, you have to get out of the bottom, which means you have to multiply both sides by x. Okay? So basically, we're just gonna, I guess I can show it on this. I thought I'd already shown it, but I'm just gonna rewrite the problem. To get it out of the bottom, we have to multiply both sides by x. And what that will do is it'll cancel the x's on the right. And now we are left with x times sine of 33 equals 6. Okay, so we got x out of the bottom. The next step is right below that. We are now going to divide by sine of 33. That way, we will get rid of the sine of 33 on the x side, and x will now be by itself. So just to reiterate, we had to multiply both sides by x and then divide by sine of 33 on both sides to get x by itself. So now we have x equals 6 over sine of 33. That's what we're going to plug into our calculator. So whenever x is on the bottom, you do end up typing something in your calculator where you have a number on top and a trig function on the bottom. Going back to our calculator, we're going to go in and type in 6, and then we're going to use this division sign right here, divided by, and you can actually just type in SIN on your keyboard, sine, and then 33. We get 11.016. Round to the nearest mile, and that's 11 miles. Putting this back into context, we were figuring out how far away you are from the plane. That would be this hypotenuse, which is 11. Therefore, the observer is about 11 miles away from the plane. That's it. We've solved all of our practical trig problems, going through those 5 easy steps. If you have any other questions about solving these out, setting them up, drawing the pictures, or any other question related to this lesson, let me know.